Hello again, this is Randy. Today we're going to briefly review every topic that we have learned in the polynomial graphs unit. Let's go. So in this video, we're going to briefly review each of the previous topics in this unit. Now, if you want to see the full unabbreviated explanations for each topic, such as this topic, zeros of factored polynomials, go back to the video that has this title and you'll be able to see the full detailed explanations. So right here, we have a factored polynomial and they want to know what are the zeros. How do we find the zeros? Well, we're just going to set this factor equal to 0 and solve for x, and then this factor equal to 0 and solve for x, and then this factor equal to 0 and then solve for x. So here we started with 2x minus 5 equals 0, and then we added 5 to both sides and we got 2x is equal to 5, and then divide by 2, x is equal to 5 over 2 or 2.5. So there is the first 0. In the next factor, we just subtracted 1 from both sides, so minus 1, and we get that x is equal to negative 1. There is the second 0. And lastly, when we say x minus 7 equals 0, we just do plus 7, and then this last 0 is at x is equal to positive 7. Now, what if we have a polynomial that is not in factored form? That brings us to the topic, zeros of non-factored polynomials. So first of all, we need to factor this polynomial, and then we can set each factor equal to 0 and solve for x. So it looks like we could first of all factor out an x. So now we have x times x squared minus 5x plus 6. Now this trinomial inside the parentheses looks like a sum product pattern. So we could separate this into two binomials. Now to find the second term in each binomial, we need to ask the question, which two numbers multiplied will give us positive 6 and added will give us negative 5? Those two numbers are negative 3 and negative 2. So now we have factored form, so we're going to set this factor, and this factor equal to 0 and solve for x. So when we set x equal to 0, there's no more solving to do. So we know that the first 0 is 0. Now x minus 3 equals 0. We're going to say plus 3, and then we get x is equal to positive 3. All right, there's our second 0. And much like this 0 right here, over here, we're just going to add 2 to both sides instead of 3, and then we'll get x is equal to positive 2. And that is how you find the zeros of a non-factored polynomial. Now, I would encourage you to go back and watch more of the original polynomial intervals video if your memory feels foggy about this, because it's a little bit more in-depth topic. But we're going to do this example, and then any more questions you have, you can refer back to the original video. So they say, what is the sign of the following polynomial between the x values of negative 2 and 3? So first of all, let's draw on a number line the three zeros that we get from these three factors. So the factor x minus 3 gave us a 0 of positive 3. The factor of x gave us a 0 of 0. And the factor x plus 2 gave us a 0 of negative 2. Now, where is the interval they're asking about? It starts at negative 2 and ends at 3. So it starts here and ends here. Now, as we discussed in the polynomial intervals video, because we have a 0, in this case, the 0 is 0, in the middle of this interval, we know the graph is going to cross the x-axis at this point inside the interval because there is no multiplicity. So because the graph crosses the x-axis, we know the sign changes at x equals 0. And therefore, the sign in that interval is both positive and negative. So for more details about the special cases in the polynomial intervals topic, I would really encourage you to go back and review that original video again. So when you are asked which function could represent the graph given, you'll be given a number of possible answers, and you'll have to choose one. So just by looking at the zeros of this graph, so we can see that there's a 0 at x equals negative 2, a 0 at 0, and a 0 at positive 1, we can determine a possible factored polynomial that would give us this graph. So a possible factor that would correspond to this 0 would be x plus 2 squared, because squared tells us that the graph does not cross the x-axis, but it just bounces off. Just like if we had an exponent of 4 or 6 or 8, any even exponent, that would tell us that the graph would just bounce off the x-axis but not change signs. So this right here is one possible factor that would give us this 0. Now what about the next 0 right here? Well, first of all, it looks like we're going to have an even multiplicity because it once again bounces off the x-axis. So it's going to be something squared or something to the 4th or something to the 6th, etc. And as we've seen many times, when we have a factor that is x or x squared or x to the 3rd or x to the 4th or x to the 5th, that will give us a 0 at x equals 0. Now, the exponent is even, as we've discussed, because it does not cross the x-axis. Now, what is one factor that could correspond to this 0 at positive 1? Well, x minus 1. Now, what about multiplicity? Looks like the graph crosses the x-axis at this point, so the exponent on this factor needs to be odd. So the most likely exponent on this factor would actually just be 1, because if we had like a 3 or a 5 or a 7 as the exponent, then this graph right here would make kind of a squiggly S shape as it's crossing the x-axis, but in this case it doesn't do that. So given all of these factors from the zeros on the graph, one possible function to represent the graph would be f of x is equal to x plus 2 squared times x squared times x minus 1. Now we need to describe the end behavior of this polynomial right here. In order to determine the end behavior, we just need to look at the highest degree term, which in this case is first. Is this exponent even or odd? It is odd. And is this leading coefficient positive or negative? It is positive. That means that our polynomial will start low and end high. We know the graph really goes for infinity in both directions, so it's even more accurate to describe this behavior mathematically, as you can see here. Next one. According to the remainder theorem, f of x divided by which of the following linear expressions will give us a remainder of 0? Now, although we discussed a lot of theory in the remainder theorem and graphs video, we know that the correct answer here is going to be the answer that is a factor of our original function, which is, in this case, option B, x minus 2. And just like in the previous example, we discussed a lot more theory in the original factor theorem and graphs video, but today we'll talk about just the shortcut, and that is the answer to this question is going to be a factor of the original function. So when they say name one linear expression that corresponds to a root of f of x, your answer could be x because of x cubed, or x plus 2 because of x plus 2 squared in the original function, or x minus 1 because of x minus 1 in the original function. So all three of these would be possible answers because all three of these are factors of our original function. And lastly, don't forget to go back to the original videos for any of the topics that we've discussed in this video if you want more review. And with that, we are finished. See you next time.